Hey folks, my name is Pat and my partner is William Short, and today we'll be talking about quantitative risk assessment techniques that you can use to help delineate project risks. Here's a brief overview of the sections we'll be covering in the video. So, why perform a quantitative risk analysis? It's not always an appropriate tool to use. Certain projects aren't big enough or critical enough to justify the costs. It's really most appropriate for large slash complex capital projects that have a lot of uncertainty around them and projects that are strategically important to the organization. So projects that are critical to the future of the company really merit this level of analysis. Before we get into the techniques, we wanted to touch on the inputs that are required for a quantitative risk assessment. This figure is from the PMBOK, so you can see you need a project plan. So we're at step 7 in that figure at the start of each chapter in our text. There's also numerous project docs that are required, and you'll need some enterprise slash organizational information as well. This all feeds into the analysis, and then you generate a risk report on the other end. And to break down those inputs a little further, so you'll have a scope and some initial baseline estimates. You may also have a risk management plan outlining potential risks. There can be a whole host of project documents, including cost and time estimates, as well as forecasts. And then enterprise and organization inputs can be published material, commercial databases, or data from similar projects. So when preparing a quantitative risk analysis, it's useful to have a subject matter expert on staff to help with choosing the appropriate techniques and which inputs to use. They're also able to help with interpreting for other stakeholders. Gathering data is obviously a key step. Data can be internal or external, and it doesn't just have to be limited to numerical information. It can be qualitative as well, such as interviews, for example. And then you need to represent uncertainty. So this normally means assigning probability distributions to your data. There are different types, but the most common is a normal distribution. The expert can help with this step as well. So the first technique we're going to talk about is a simulation. These models simulate the combined effects of individual project risks to predict their potential impact on the project objectives. They're typically done using a Monte Carlo analysis. So if you're trying to estimate total project cost, your inputs will be your cost estimates naturally, and the Monte Carlo sim will run tens of thousands of simulations to give you the most likely outcome. A typical output could be a histogram showing the number of iterations, or often PMs will use a cumulative probability distribution or an S-curve like the one shown here. So here you can read off the graph different predicted total costs and their respective probabilities based on the inputs this model was given. The next major technique is a sensitivity analysis. This analysis helps project managers determine which risks have the most potential impact on outcomes so they can narrow in on and mitigate the most important ones. You'll often see a sensitivity analysis displayed as a tornado chart, like the one here. This example shows the correlation various risks and other activities have with project duration. The items are listed in descending impact, giving the chart its tornado shape. These tornado charts, as well as S-curves, are great, easy to read visuals that go well on a dashboard, and they make it easy for PMs to glean insights from quickly. Another technique is a decision tree analysis. This is a useful technique for supporting major decisions. So the example here is build or upgrade. Then you can illustrate the different paths through the project. You have different nodes with an action represented by a symbol. The chance nodes have probabilities attached to them. So you work your way through each branch and evaluate the expected monetary value at the end of each one. And then you go with the option that makes the most sense for the project. The last major technique discussed in the PMBOK is influence diagrams. These are graphical aids to help with decision making under uncertainty. Similar to decision trees, influence diagrams have various nodes that represent different things. They can depict an entire project or just a specific situation within a project. You put it together and then you would evaluate it using some kind of simulation again, like a Monte Carlo analysis, to delineate which elements of the diagram have the greatest influence on key outcomes. So the outputs from an influence diagram could actually be represented with an S curve or a tornado diagram mentioned earlier. A quick word about outputs. So one of the key outputs from these techniques would be a risk report. This should include items such as the overall risk exposure of the project, probabilistic analysis. It should prioritize the risks, and it normally includes recommendations on how to proceed. A word about limitations on this stuff. Obviously, these models can get complex. You don't want them to be too simple, but you also want to avoid going overboard with details. There's a sweet spot of complexity that delivers good value. Also, these techniques shouldn't be used in isolation to make decisions. Rather, they should be one tool in a project manager's toolbox to support decision making. So always use them in conjunction with other maybe qualitative techniques, for example. And then be aware that human error can occur. More recently, with the use of big data, human bias has crept into these models. Uh, and this can obviously have an effect on outputs. So always take the outputs with a grain of salt. So we thought this was an interesting example. NASA and Lockheed Martin are working together to plan a manned mission to Mars. It's not just Elon Musk trying to do this. It's a multi-phase, multi-year project involving several unmanned as well as manned missions to collect data. We've included their master schedule there on the left. You probably won't be able to read much off this, but it's just to give you a sense of the complexity. So you can see there's multiple years up top. There is a critical path defined in there somewhere as well. And because there are so many stages and expensive technologies in play, risk forecasting was deemed necessary, specifically schedule risk. For their inputs, they had a lot of historical data and extensive expert judgments, which is nice. It makes assigning uncertainty a little easier. So the Lockheed team are using a simulation to determine key information on major milestones. For example, when a launch is going to take place is obviously a critical date to know. They run this simulation on a monthly basis as an iterative process to improve the accuracy of the predicted milestone dates. So on the right here, you can see the historical S curves for the phase one of the project. They run the simulation, which highlights the major risks. They take corrective actions to manage those risks. And then you see over time, the S curves become more clustered, giving a more accurate prediction of the milestone completion dates. And that is it for quantitative risk techniques. If you have any questions, please leave them in the chat and we'll get back to you. Thanks.